GeneralFoundry Incorporated, a metalworks plant in Milwaukee, has long tried to avoid the expense of installing air pollution control equipment. The local Environment Protection Agency has recently given the foundry 16 weeks to install a complex air filter system on its main smokestack. GeneralFoundry has been warned that it may be forced to close unless the device is installed in the allotted period. Lester Harkey, the managing partner, wants to make sure that the installation of the filtering system progresses smoothly and on time. GeneralFoundry has identified the 8 activities that need to be performed in order for the project to be completed. Those activities and their immediate predecessors are shown in the table below. This is a project management critical path example. When I do problems like this, I start with the following headings on my worksheet: activity, predecessor, time, earliest start time, earliest finish time, latest start time, latest finish time, slack, and critical for critical path. In addition, I add 2 columns to help students keep track as they work through the process. One is the forward pass. The first step in the forward pass involves the earliest start time. The second step, the earliest finish time. Then the backward pass. The first step in the backward pass is the latest finish time. The second step is the latest start time. Let's enter the activities as indicated on the table. Activity A through H. And their immediate predecessors. There is no immediate predecessor for activity A or B. And for C, we have A and B, C, D and E, F and G. One of the first things we want to do at this point is determine the number of N nodes that we have in our network. We could draw the network if we wanted, but we can also determine the number of N nodes by looking at the predecessor column. And in the predecessor column, we want to determine which activity is not a predecessor to another activity. If it's not a predecessor to another activity, that means it occurs at the end. So it's an end node. We have A, B, C, D, E, F, and G as predecessors. The only activity missing is H. That means that H is the end node, and there is only one end node. We are provided with the time in weeks. Activity A is 2 weeks. Now we have the time in weeks for each activity entered. We can go ahead and start with the forward pass. Pretty straightforward. The earliest start time for an activity with no predecessor is 0. It starts at the beginning. The earliest finish time for all activities in the forward pass will be the earliest start time for that activity plus the duration or time it takes to complete the activity. That will be true for all activities. Again, an activity with no predecessor begins period 0, and it finishes with the start time plus the duration of the activity. And since this is the formula for all finish times on the forward pass, I'm just going to copy that down. And as I enter the earliest start time for each activity, the earliest finish time will automatically update. So activity C cannot begin until activity A is completed. So the earliest start time for activity C is the earliest finish time for activity A. And as you see, the earliest finish time for activity C is updated. Activity D cannot begin until both activities A and B are completed. So activity D begins with the maximum of the earliest finish time for either activity A or, activity B. It's important that you do it this way. If for some reason the times change and the time for activity B should become less than the time for activity A or vice versa, your table would automatically be updated and remain correct. Activity E, start time, is the finish time for activity C. F is also the finish time for activity C. Activity G is the max of the finish times for activity D, and activity E. You'll notice that on the forward pass, when we have multiple activities, we use max to determine. We take the largest of the finish times of the preceding tasks. And activity H equals the max of activities F, and G. We're done with the forward pass. Now we begin the backward pass at the end. That's why it's a backward pass. It moves backward through the network. And the latest finish time for our activity, we know it's the finish time for activity H. So rather than type in 15, we will point to the cell 15. We can calculate the latest start time if we know the finish time is 15 weeks. And we know that the duration of the activity is 2 weeks. We can subtract 15 weeks, 2 weeks. Now to complete the remaining activities, we want to take a look at the predecessor list. We are on activity G. We look and we see that activity G is the predecessor for only one activity. That's activity H. So the latest finish time for activity G is the latest start time for activity H. Activity H can't begin until activity G is finished. Activity H begins in week 13. Therefore, we know that activity G must have finished in week 13. Again, if we know when the activity finishes and we know the duration of the activity, we can subtract the duration of the activity from the week in which it finishes and calculate the week in which it starts. This is the case for each of the start times in the backward pass. They all use this formula. Because that's the case, I'm just going to copy that formula all the way up, and then it will update as I complete the finish times. Now I'm on activity F on the backward pass. So I look to see what activities activity F precedes. I see that activity F precedes only activity H. So the latest finish time for activity F is the latest start time for activity H. Activity E, I'm on activity E. I look in my list of predecessors, I see that activity E precedes only activity G. So the latest finish time for activity E is the latest start time for activity G. I'm on activity D. Activity D precedes only activity G. So the latest finish time for activity D equals the latest start time for activity G. I'm on activity C. Activity C precedes both activities E and activity F. So the latest finish time for activity C is the minimum of the start times for activity E and, comma, activity F. The reason we use the minimum here is that an activity can begin as soon as its predecessor is finished. So of all of the activities for which activity C serves as predecessor, the one that starts the earliest, the soonest, since none of them can start until activity C is completed, the one that starts the soonest is the one that indicates when activity C actually ended. Therefore, the min. I'm on activity B. Activity B precedes only activity D. So the latest finish time for activity B is the latest start time for activity D. I am on activity A. Activity A precedes both activities C and D. So the latest finish time for activity A is the minimum of the start times for activities C, comma, and D. On the backward pass, I use min to determine the latest finish time for activities that precede more than one other activity. On the forward pass, I use maximum to determine the earliest start time for activities that are preceded by other activities. I have to wait until all of the preceding activities are completed before I can start, so I use the maximum. To calculate slack, we subtract start time from start time or finish time from finish time. It doesn't matter, yield the same result either way. I usually want positive numbers, so I start with the backward pass and subtract from that the forward pass value. I use finish times, so I'll take the latest finish time and subtract from that the earliest finish time. I do that all the way down. That shows me the slack for each activity. Activities with 0 slack are activities on the critical path. I tend to use ones and zeros. You can use yes and no, whatever you want. I use an if statement. If the slack for this activity equals 0, then it's on the critical path. Otherwise, it's not on the critical path. So activities with a 1 are on the critical path. To help you out here, I'll just put critical equals 1 in the label. I'll determine my critical path. You have to do this manually. The values here for the critical path correspond with the ones in column I. So we have A on the critical path, C, E, G, and H. And the project length is, that value will always be at the end node, latest finish time. Project length is 15 weeks.